Alrighty, so this is 5E, transformations of radical functions. The transformations that you see here are the ones that you've seen a million times since Algebra 1. So I would pause the video, make sure to fill those in if you need them. The transformation form of the root function looks like this. Now, the transformations with root functions tend to be confusing for kids because often there's a number kind of chilling right here. Usually we call that B. And the majority of this video is going to be focused on how to get rid of that B. We turn it into the A value. All right, so this section wants us to identify the transformations for the functions. So starting out here, the negative right here in front of the 2. This is your A value is -2. So the negative gives you the vertical reflection. And the 2 gives you the vertical stretch. Remember, your A value can have those two separate things that happen. Just imagine the 2 as the magnitude, which is why we started putting the absolute values on here. So the size of the number has to be bigger than 1. All right, now this +4 makes it an H value, right? And that is a translation to the left. You need to make sure that when you're describing translations that you use the word translation. Some of y'all just use directions, and that's not true. Because a direction isn't actually telling you what's happening. A direction is just saying which way it happens. Also, some of you guys are still putting negatives when something moves down. That's like describing, I walked -5 miles last week. That doesn't make any sense. So the direction here tells you whether it's positive or negative. You don't need to put negatives on there because we don't measure distance in negative units. All right, let's try it with this cube root function. Okay, so the 1/2 is my A value. That is smaller than 1, so this is a vertical compression. My H value says -13 here, so that's a translation right 13 units. All right, this +12 is a K. That is a translation up 12 units. All right, seeing it from the graph can be a little difficult for us with these because you guys aren't as familiar with your shapes of the graphs here. So this piece right here is my vertex. It's at -3, -2. Okay, so the -3 here is your H value. So it was translated left 3 units. The -2 is your K value, so it was translated down 2 units. Oh, come on. Now my handwriting wasn't that bad. All right. Now the A is the one that kids get a hard time with, okay? So what I do to find A is you always go 1 box to the right, okay? Your A is however far up or down the graph goes when you go 1 box to the right of this main point. So coming 1 box to the right and coming up, that gives me an A value of 2. So this had a vertical stretch. So if I were to write the equation for this, which I don't ask you to do in the instructions, but that might be nice. We have 2. This is a square root of function. X +3, and then the down 2 units would be -2. That's a weird looking 2. Let's fix that. Notice this -2 is outside of the radical house. So make sure that you put it outside the radical or you're going to start getting wrong answers, especially when you take it back to Sabbath. All right, so this is a cube root function. So I'm looking at the center of what I call Orion's belt. That's the 3 points that are all in a row here. That little belt buckle is how you determine your H and K. So this is at 2, 1. So my h here is the 2, which is a translation right. The 1 is my k value, which is a translation up. And then to find my a, again, I go 1 box to the side. This one went 1 box down, so that means that my a is -1, which is a vertical reflection. So if I were to write out the equation for this, right, I'd say f of x equals, now this is a cube root, so I made a cube root here. My a is just going to be a negative sign. For my h, that would be a -2 for the translation right. And then I have a +1 outside of the radical house. Now remember, sometimes you might see it written like this, where they move the k value in front of the radical. Often a lot of textbooks will do that because kids struggle so much with the length of the radical and what it covers. So for clarity, sometimes you might see it like that, and it still has a -a, and it still has the +1. It just looks a little different, which could be confusing for kids. Now, like I said, sometimes we need to rewrite radical functions because we can't see their transformations. That's when you have a number here in front of x, which happens pretty regularly. So our procedure, which we know and love here, we're going to factor out the GCF out of the radicand. All right, you're going to take or find the nth root of the GCF. Use that to identify the new a value, and then you can list the transformations. All right, so let's give it a go. So on this cube root, I have an 8 in front, so I'm going to divide the 8 out. I'm factoring it out. So when I do that, I need to remember to divide it out of the 8x, and I have to divide it out of the 24. So the 24 turns into a 3. Now, I could find the cube root of 8, okay? 8 is 4 times 2. 4 is 2 times 2. So the cube root of 8 is just 2. So if I put all that together, I can multiply the 2 that I just got times the -2 that was already chilling there in front. So I'm getting the -4 from. And now this is in that transformation form. There's not the number that's sitting in front of x. So if I'm identifying my transformations, okay, I have a vertical stretch from the negative on the 4. The 4 itself is a vertical, I'm sorry, the vertical stretch comes from the 4. I have a vertical reflection from the negative on the 4. My bad, guys. The x plus 3 is a translation left 3 units. And then the plus 6 here is a translation up. All right, I'm going to do it just a couple more times here. This one's a square root instead of a cube root, but the process is still the same, okay? So I start by taking the number that's in front of the x, and I divide it out. Now I do it to the 50 also here. So 50 divided by 25 is 2. Now 25 is 5 times 5, yeah? And so I'm going to multiply that to the 3 that's already vibing there in the front. So 3 times 5 is 15. And sometimes those a values can be kind of weird. Sometimes your a value will still be a radical, which could be awkward for some folks. All right, so our a value is 15, so that's a vertical stretch because it's bigger than 1. The plus 2 is a translation left 2 units. And the plus 7 is a translation up 7 units. So notice your h isn't the same thing when you start as when you end. So you need to make sure that you find your new A value before you identify H, because you got to factor that number out. So here's another one that we're doing, and this is one of those that I said was going to look a little weird. Okay, so be ready for a kind of strange answer. Okay, so I'm taking the cube root of 3 and I'm dividing it out. And so 7 divided by 3 is 7/3. And I can't take the cube root of 3, so he's just going to chill as the cube root of 3 out there. Okay, so when you do this, what is the cube root of 3? Is that bigger than 1 or less than 1? So I'm hopping over to Desmos because I don't actually know off the top of my head. I also don't remember how to take a cube root on Desmos on this thing. So one thing I could do is I could look in here for the weird looking radical, which is right there. Or you could have just raised 3 to the 1/3 power. So the cube root of 3 is 1.4, which is bigger than 1, so that's a vertical stretch. All right, my negative 7/3 there is a translation to the right. And then my plus 5 here is a translation up. So be ready to factor out GCFs. Be ready for kind of weird A values. But it's not too much different than what you've seen in the past. Make sure to check your announcements, okay? Make sure that you know what your due dates are. And when you're